Okay.
So I made
Yes.
it full screen here.
Just a second, just a second. TST meeting, we're getting started. I am now recording, so we're going to hear a presentation from folks from Mellanox about their collaborator proposal, and then we'll discuss it for a little bit. Go ahead, Jolie.
Okay, so we have probably like 6, 7 slides that shows the Mellanox proposal to open Cord. Basically, it's an acceleration framework so that we can help the virtualized network functions and SDN applications run better, meaning higher throughput, lower latency, higher performance, and higher efficiency. So we measure efficiency in terms of mostly the CPU overhead, because our philosophy is more towards the offload versus onload. So we offload some of the CPU-intensive network processing operations from the CPU to either our NIC that can be ASIC-based, FPGA-based, or multi-core based, and also we have a network infrastructure that mostly consists of our Ethernet switch products and our network processor products, the NPS, that can drive better packet processing performance. So this is an overall picture of our proposal. We modeled this after the trellis architecture for Cord. So it looks probably very familiar to you. So these are the REM and A Cord that's defined by the Open Cord organization. And our contributions in terms of hardware would be in the server infrastructure. So we have our ConnectX-4 series of NICs. So I just put ConnectX-4 here. So ConnectX-4 has 2 flavors. So one flavor is ConnectX-4 that supports anything from 10G to 25, 40, 50, and 100G. And then we also have a more compact version of the NIC that supports 10, 25, 40, and 50 gigabits per second of throughput. But it's more cost effective and more optimized for Ethernet. And aside from, based on the most basic ConnectX-4 NIC, we also have other flavors. We have a FPGA flavor NIC that can do security type of acceleration. And we also, in the last couple months, we announced a multi-core version of NIC called Bluefield. So basically, it's just a series of ARM processors that can that's optimized for packet processing, and you can flexibly program the NIC to perform the network functions you need. And then the second major component is our network infrastructure component. So this is consisted of our signature Spectrum switch. So our Spectrum switch is designed to better handle small packet processing, and also in terms of fairness and latency and power. Spectrum has very significant advantages compared to some mainstream switching products. Somebody has a question? Okay, so we'll continue. And then Sandeep is here. So he is our NPS expert. So our NPS is a network processor product that we envision can be combined with our Spectrum Ethernet switches. So this would be an intelligent Tor type of offering that's on the roadmap. So basically, with a combination of a commercial off-the-shelf switch silicon and a more intelligent network processor. The network infrastructure itself can provide better layer 2, layer 3 handling, and also added features such as firewall and other security features.
This is Larry. The network processor, I'm trying to fit it in. I mean, the NICs are augmenting the servers. The switches are building out the switching fabric. Where do the network processors fit into the leaf spine?
Yeah, so this model, let me just say a couple of things about the NPUs. This is Sandeep. If the port density, it is not very, very high, so for example, total of, say 1 terabit instead of 3.2 terabit, then the network processor can be in something like a top of rack, where you would get the typical L2, L3 features that other switches do, but you can do a lot more things. You can do full, for example, OpenFlow 1.3, 1.4, whatever the latest spec is. You can do all kinds of statistics gathering, all the way L4 to L7. You can do stateful processing on flows. You can do things like IPsec SSL offload. You can do anything that you can define because it's based on a fully programmable engine. You may already.
So just to make sure I heard you would envision it as an alternative top of rack switch.
It depends on the density. So certain carrier top of racks, they still use 10 gig. And if you were doing something like 10 gig by 48 with 100 gig uplinks, the NPS would work fine today. If you were doing 25 gig or if you were doing 48 by 25 plus 6 by 100, then the Spectrum class is the right thing. But you may already be familiar with our NPUs today because the Radisys, some of the Radisys products use our NPUs. You may have used the NoviFlow, NoviSwitch, which is all based on our NPUs. And I think NoviFlow is probably the highest performance, fully, full OpenFlow 1.3 with every option, enabled.
Got it. Thank you.
So those, NoviFlow switches also cost about 6 times the standard ASIC-based top-of-rack switches. So that makes it really hard for us to present an NPU-based top-of-rack or spine switch as part of the hardware fabric. And also, as far as I know, the NoviFlow-based switches top out at around 400 or 500 gigabits per second switching bandwidth. So I was surprised that you gave the 1 terabit per second switching number.
Yeah. So let me just explain. So our NP4 was a 100 gig NPU, or NP5, which is what the NoviFlow current product is. It was a 240 gig NPU. The NPS, has a 960 gig of throughput. So it's the the software ports forward, but the hardware basically is what generation is current. So NoviFlow current products are based on stuff that we had 2 years ago. Everything we're shipping now is NPS based, where NPS is 960 gig of I/O and throughput.
And the cost for these latest generation ones, when we put it around some hardware, say 3 times, 5 times, 6 times an ASIC-based top of rack, or?
Okay, so cost is a very kind of nebulous thing, because something that costs $100, if nobody else in the world has it, I can sell it for $1 million. So if you just look at what is what is an ASIC versus what is an NPU, yeah, the base cost of those will be different, but the actual system level cost for something that's 1 terabit, if it's a white box, let's say you buy a white box Spectrum versus a white box NPU, it actually won't be it'll be a few hundred to a few $1,000 delta. And the 5 or 6x is only because people are extracting value and saying, okay, you can buy, a $500,000 Cisco router, Juniper router, or you can use the same chips that they do in a white box, with advanced software, and I'll give it to you for 50,000 instead of 400,000. So cost is actually, I mean, you guys should know that you're open sourcing everything. You're using white box, and your open source products should be able to do things, at 1/10 the cost of proprietary products. So we're the same thing. If you use a white box based NPU, which is becoming much more common, then the cost will be really the cost of the BOM, and the software should be open source software. So just because an advanced company like NoviFlow is selling something that might be very expensive, they're doing it because that's their value. I think you should look at it as, okay, it's a white box with open source software. What is the silicon difference? And it's actually not that different.
Are any traditional white box vendors, ODMs, putting NPU-based switches?
They are. We're actually, working with several ODMs that already have, shipping systems. I don't know what's public, what's not public, so I don't want to get into specifics here, but maybe we can offline. So, because this is a public presentation, I just don't want to give names of people that may not be public. So.
Thanks.
Okay, so I saw that Tel Anchor just dialed in. Tel, are you fully dialed in? Are you on mute?
Yes, Chloe, I was on mute. Yeah, I'm dialing and watching the presentation to the Citrix, and I go to meeting and I'm connected via the phone to the audio.
Okay, so actually, I am going to, the rest of the slides are the technical slides that Tel created. So I am going to let Tel present. So Tel, I'm going to advance to the next slide. Let me know when you want me to advance.
Okay, sure.
Okay. Hold on. Not, okay. Okay, so I guess there's no need to reiterate about the ATN of the architecture, so probably all you guys are well aware to that. So Mellanox is playing a focus on the infrastructure of the NVI portion of the ATN of the architecture. The goal, as we see it, is to reduce the overall NV infrastructure cost while boosting the performance and maintaining deployment complexity the same, or even if possible to reduce it. The means to achieve the above goal is by adding multiple offload engines and functionality to the hardware, be it a network interface card or a switch or NPU, while exposing the hardware services of these entities to standard software tools and mechanisms. The best, and we think that we have the best infrastructure performance in the market today, both for the server side and the network infrastructure. So next slide, Chloe. So just some of the highlights when I say best infrastructure performance. So we have on the host server or VNF side, we have the technology that we call accelerated switch and packet processing, or ASAP². This is all about vSwitch acceleration. Current performance is 66 million packets per second with 64 byte packet size and 0 CPU load on the hypervisor. The number actually varies. 66 million packet VPS is for few flows, and we can get up to millions of flows. Currently, when you go beyond 60,000 flows, we get about 15 to 18 million packets per second. We have the best DPDK performance. We have over 88 million packets per second of forwarding in DPDK. IPsec performance, which is a work in progress. Currently, we have
on the host side. We have 30 gigabit per second of IPsec traffic, and the goal is to reach 40 gigabits. This is something that we work on. And we also have the legacy cloud stateless offload engines, what we call VCAN, NVGRE, stateless offload, RSS, LSO, TSO. These are all the TCP offload engines that are enabled using our card, so that the host operating system they would not have to work hard on parsing packets or doing checksum, etc. So these offloads are again utilized in legacy cloud, but also obviously in NAV. On the network infrastructure side, which is sometimes called the fabric, and I'm talking here about the top of rack switch and above, we have a zero loss, full wire speed, 64 byte low latency switch that can get up to 3.2, currently 3.2 terabits per second. And the next Silicon Spectrum 2 would be twice than that. We have the NPS. I heard Sandeep covering the NPS stuff. So we have the NPS, which we have either as a standalone or as part of the intelligent Tor offering. So the NPS has a 400 gigabit per second stateful flow awareness and 400 gigabit DPI, with 2 million connections, new connections per second, 200 gigabit IPsec. All of these are available through the NPS itself. Next slide, Chloe. So here we see the offering break down into various components in the NAV realm. So the right-hand side upper portion, we see the server. And the server itself is split among the VNF and the hypervisor. So I'll start with the hypervisor. The hypervisor we have, as I said, the ASAP Square Direct. This is the accelerated switch and packet processing direct, which is Mellanox's ability to accelerate the virtual edge bridge. The most prevalent virtual edge bridge today is the OVS Open vSwitch open source project. The IEEE standard defined all the switching entities, total switching entities that actually run on the server side and switch traffic between the VM. All of them are termed VEB, Virtual Edge Bridge, and OVS is the open source prevalent implementation of OVS, and ASAP Square Direct actually accelerated. It's accelerated by enabling replacing the data plane of the OVS that runs in the kernel, and moving most of the packet processing to the NIC, to the embedded switch on the NIC, while retaining the control plane, the vSwitchD, so that any SDN controller, ONOS, ODL, whatever, can still manage the host using the same OVSDB and OpenFlow protocols. However, the data plane is augmented with our NICs, and thus we get up to a really high numbers of million packets per second forwarding.
Could I ask a question? If on the server, this is Larry, on the server, I see integration with OpenStack, and so you have the cloud management Vim aspects of it. But if I just focused on a single server, this is just a standard Ubuntu with some your specific drivers and some optimizations. I could just view it as a regular. I could control it my own way if I wanted to, as a regular vanilla Linux box with some extra capabilities. Is that correct, or is?
No, that's correct. We are currently in the process of we work always, with the open source community is making everything upstream. So our changes that we need to add for the OVS software for the ASAP Square Direct, most of them are already been pushed upstream, and the changes to the OpenStack, we have them already implemented. Are minor changes. As a matter of fact, I just worked today with one of the R&D guys to provide a blueprint for that. There are kind of minor changes, and we expect them to be accepted by no later than the end of the year. So yeah, in essence, you can take our NICs and you can run OpenStack and use the regular Linux, and you can actually consume the ASAP Square Direct services, the OBS offload services.
And all of that software augmentation is all open source.
Yeah, we're making everything open source.
Yeah, okay.
Absolutely. So, getting upstream in OpenStack actually relying on the fact that all other components are already upstream. So that's why we kind of delayed with OpenStack, because we had to make sure that all the other relevant kernel changes, we provided something that is called representer port. I won't dive into the details here, but we had to make sure that everything change that we need to add to the kernel have been upstream before we can actually push changes to OpenStack. Because when you try to push something into OpenStack, everybody assumes that everything that you actually rely on is already upstream. So that was delayed a little bit, but as I said, it's hopefully going to be upstream in the next couple of months. So that's for the ASAP Square Direct, which is actually the virtual edge bridge acceleration. This version of OBS offload or ASAP Square is actually relies on SRIOV, on virtual function. That's why, by the way, we call it ASAP Square Direct. In OpenStack, the direct port is a synonym to a virtual function, to a SRIOV base. And there are some partners of Mellanox that actually want us to have another solution that is not relying only on SRIOV and virtual functions. We think that the SRIOV offload or the ASAP Direct offload of the OBS is the best performance-wise and latency-wise. By the way, it's also reduced the latency, and the performance is predictable. Latency is predictable. That is what we actually try pushing with some of our partners. However, in some cases, some partners do not want to use SRIOV, so for that, we have the ASAP Square Flex. ASAP Square Flex is the ability to take portion of the packet processing pipeline that any switch has, be it a software switch or hardware switch. Any switch has a predefined pipeline, like you do classification, you do QoS, you do NCAP, DCAP, and at some point you also do the switching action itself. So if you look at this pipeline, ASAP Square Flex takes a prefix of this pipeline, implement it in the hardware, but we leave the actual switching to be done in the software. So this way we actually enable para-virt interfaces. Virt.io is enabled when you're using ASAP Square Flex, so you don't use a virtual function or SRIOV when you're using ASAP Flex. However, if you do ASAP Square Flex, the vSwitch software still needs to switch every packet. However, we reduce most of the load. For instance, every flow-based switching, including the OVS, is doing a lookup on a flow. It has to look up at the cache to find the right flow, and then the right flow entry tells him to which VM the packet needs to be forwarded to. So what we do in ASAP Square Flex, we do the classification in the hardware. We provide the flow ID or flow tag to the kernel, to the vSwitch data path, and the vSwitch data path looks at the flow tag and switches the packet according to it. So that removes about 140, 150 CPU cycles from the OVS data plane. That's a lot.
Excuse me, I'm conscious of time, and I think we're going to have some questions after I'm wondering how many more slides you have here.
I don't have a lot of slides, but every slide has a lot of context. So I can speed up. I can go through the other stuff, and then if you have any questions, hopefully we'll have time for that.
Let's try the following. Let's jump to, I think there's a particular question that we need to address, and then we can see if we need more backup slides to support it. But I think the high-level takeaway, it's been helpful to learn some of the details, but the high-level question in terms of Cord Collaborator is hardware all is great, and you've definitely got value in terms of how you're going to accelerate NFV, and you can show how you can retrofit it to Trellis, and yeah, there's issues of value, slice cost, and all of that. Leaving that all aside for a second, the real issue for us is if you bring hardware like this to Cord, and you leave it at our doorstep, so to speak, it will just sit there because we don't have the the engineering resources to do anything with it right now. We're focused on a robust implementation with a limited set of hardware so that we can demonstrate all the value of Cord on that. How do you see this hardware being incorporated? What do you see as the path for this hardware being incorporated into Cord? I mean, it doesn't perfectly match the Cord model. There will be engineering work to do. It's not going to run off the shelf in Cord. It just isn't, because there are other aspects to Cord. There's the way we do overlay overlay virtual networks. There's the way that we do segment routing in the switching fabric, and so on and so forth. The way VNFs get managed, and there's going to be engineering work there. So I think one of the critical issues is how can we think about that kind of work getting done?
Okay, so as for the switches, for instance, of Mellanox support the regular standard interfaces, and I don't see almost any engineering work needed there. The standard layer 2, layer 3 switch, we're going to have VTEP support in the coming 2 months, OVSDB, regular mechanism, regular protocols to manage the top of rack switch.
So is it
as for the
just on that point, is it part of the proposal that you would actually stand up a Cord pod with your hardware? Is that the way we should think about it?
I think so. I think that's the idea.
So,
if I understand.
So basically, Larry, you mentioned that you see some potential gap in get this set of hardware up and running in Cord. What are some of the major concerns? Well,
I could let the other people in the TST chime in with their own, but just focusing on the VNFs in particular, we don't follow precisely the ETSI architecture. I mean, there's a way to do the mapping, but we don't. We have a particular style of onboarding VNFs into Cord. The composition, or as you would call it, the service chaining between VNFs is basically managed by a combination of XOS and Virtual Tenant Network, VTN.
Okay.
If they're going to take advantage of the hardware other than a simple drop-in replacement for the white box switches we currently have, there will be engineering work there. And even if it were minor, even if we couldn't itemize it specifically, just the effort to bring up a pod with a particular configuration of hardware is that has not been run before, typically takes effort.
Okay, so assuming that we are going to dedicate some resources to stand up a Cord pod, what kind of collaboration or help we can get from the Cord organization in terms of standing up the software, etc.?
Well, I think if you have been watching the mailing lists and Slack, you will see there are lots and lots of people who have their own. They didn't just take our hardware. They said, no, I've got Dell servers. I don't have these OC Quanta servers. I've got this switch. I got that switch. And they actively are asking questions, downloading the software, submitting patches when something's broken. It's just a typical collaborative open source effort at that point. It's not as though we assign an engineer specifically to go work with any one of those.
Okay.
Typically, any one of those companies will have some engineer or two working on it, asking questions and giving us feedback. I mean, you look at that. It's kind of hard to tell for the mailing list sometimes because everyone's got a .gmail address, but from pretty much all of the active collaborators, you'll see that kind of activity. Okay,
so this is the path you recommend that we will take.
Yeah,
as a Cord collaborator.
Yeah, it would be great to see, I don't know, 3 months from now, whatever, that you could stand up a configuration that's running the Cord software and augmented with yours, and you boot a pod up, and then you submit patches back or whatever that enhance the platform in the appropriate way.
So if we stand up such a pod and we want to be able to show some application level benefits in terms of performance enhancement and CPU savings, etc. Currently, are there any, a set of standard benchmarks from your configuration, like your billing material, that's available somewhere?
There are test suites that we are running, and that is actually one of the big things that we're working on is to add to that. So helping to craft the right set of benchmarks would be very helpful.
Okay.
Yeah, my recommendation is that instead of thinking about the entire Cord pod with everything like the switches and servers and NICs, everything getting replaced with Mellanox, I think my sincere advice would be to start small. Use the Cord pod as it is, but replace one unit. For example, the NICs on the servers, right? And show us that if we were running Cord with the servers and the NICs that we currently use today, and then and instead of that, we're using your NIC with, say, VXLAN offload, right? Something like that, NCAP, DCAP, right? Great. That is improvement. That's an excellent way to get started in this collaboration.
Okay, so yeah, that definitely makes a lot of sense to do it step by step. But because we're a vendor, it's actually easiest to set up something with our products because, for some of the things we can buy, but for other switches, it may not be easy for us to acquire those switches. So I think from our side, the easiest things to replace would be the top-of-rack switch and the NICs, and then this can also consistently get you up to the speed that you like. So if we want to test 25G, 40G, or 50G options, we can do that very easily because it's always in our control. So the NPS may take a little bit more work, but we're also going to have a conversation with our partner Radisys to see how we can best show the advantages of using NPS in the Cord infrastructure. But we can start with just the NIC and switch that can give us maybe a set of speeds that we want to test and benchmark based upon.
Yeah, and
we
build, you've seen the configuration for the full pod. We build partial rack pods as well. So even a demonstration with 2 or 3 servers and one top of rack switch is still a legitimate Cord pod.
Okay. So currently, I know you're working on the benchmarks. Is it per type of Cord? For example, for M Cord, you're benchmarking virtual EPC, or is it lower level benchmarks?
Well, each of the Cords, I believe, and we don't necessarily keep tabs on the latest of each one of the flavors of Cord, as from the platform perspective, but primarily the benchmarks we have performed are aggregate throughput benchmarks and in the R Cord case, number of subscribers supported per.
Okay.
Yeah, unfortunately, Zolt from Sienna is not online, not in the meeting today, but Sienna has done some benchmarking. So those numbers actually, we can request because ourselves at ON Lab, we haven't done anything. So it's Sienna, and then earlier when AT&T had done some regarding R Cord. So we can take that as an action item. to ask Sienna for the numbers that they have come up with.
Yeah.
Okay. So in terms of logistics, I know we submitted a proposal and we really do want to become a Cord collaborator. So what's the next step in terms of that part, the becoming a collaborator part?
What I would recommend is basically just, and it's not necessary that it's elaborate, just kind of summarize the discussion that we just had in terms of don't have the proposal in front of me, just a second. But in terms of proposed deliverables, essentially just say, the plan of action, so to speak, is that we will stand up a pod, describe it, and then we will run some benchmarks on it. Just kind of summarize that sequence of tasks. So just augment what you've already. I mean, you don't need to tell us any more about the hardware. It's just tell us the plan of action in terms of demonstrating Cord platform with some benchmarks running on your hardware.
Okay. Yeah. So we'll take a look at. So the benchmark information, the existing benchmark information is available on Open Cord website.
No, Sienna has not yet posted. Well, I don't think there's any available.
There's
Okay.
nothing.
So the other question is, for us, we can easily stand up the infrastructure pieces. Probably we'll try to get all the orchestration keys, the SDN controller running. But in terms of running some application level benchmarks, we can also do the low level benchmarks. But in terms of application level benchmarks, are there things being done? I mean, we don't know. So for example, we work with outside of Cord, we work with some virtual EPC vendors like Affirm Networks, and I mean they've been running their application on top of our one flavor of our NICs and showed some benefit in terms of performance and basically just saving the footprint of the servers because their servers at 10G are I/O bound, and you need multiple servers to be able to deliver the performance of one traditional EPC blade. So
on the issue of what VNFs to run, the easiest place to start and the most complete end-to-end case to start would be with Cord, as opposed to
Cord. Okay.
That is the variant of Cord that runs end-to-end on the Cord platform. The mCord people are still migrating from their proof of concept implementation onto the platform. So you would be trying to meet you would be trying to meet at some point in the future with them.
Okay.
And if you have other VNFs, that would be a great thing to demonstrate. We today are primarily focused on platform and the minimal set of VNFs to run end-to-end connectivity, as opposed to an arbitrary suite of VNFs. So if you had one to propose, that would be a great thing.
Okay. So for the Cord, so my main question is normally the VNFs are not open source. So if we want to run the VNF, is that available through Open Cord, or I have to deal with the vendor?
There are the standard Cord set of VNFs are open source. You can always augment that with something that's not open source. That's fine. Okay,
got it. So I'll summarize the plan of action from this call. So people from our side, Tal, Sandeep, and Ramnas, do you have any further questions?
Not from my side.
No, but I do think their advice of starting with the NIC, the switch, the NPU of course is very, very complex, and it's already I think being used in some of the Radisys and other products they may be using. So I think doing the pod without our direct NPU, or we're doing it with an iTor, which is a Spectrum plus NPU, maybe the right way to go.
Yeah, and at some point, if you can do this in a way that teams with Radisys on the next variant of this, that would be great too.
Okay, yeah, that might be more straightforward too. Yeah.
Yeah.
Okay.
All right, so I'll look for an updated. We'll look for an updated, modified proposals from you, and appreciate your time.
And one other thought about next steps. This is David from ON Lab. Also, in addition to that proposal, I'll be able to help you work on sharing this information out and promoting it with the community. If you could send me the Mellanox logo, I'll be happy to get it on the Cord site, and then I'll connect you with our PR people, and we'll get this news about this relationship in an upcoming press release.
Okay, that would be awesome.
And
so I will send the updated proposal along with our logo.
Awesome, great.
And if you could share the slide set, so offline we can go through it, that would be very helpful as well.
Okay, yeah, I'll have a quick chat with Tal and then send the slides over.
Yeah, and also Bill recommends that whatever you share with us, please take out Mellanox confidential.
Right, I understand.
Thank you.
Okay, thank you, everyone.
Thank you.
Thank you.
Thank you. Thank you.
So we only have a few more minutes. And the other thing I wanted to talk about, well, let me see if there are any other agenda items before I just raise my issue. Not hearing any. I wanted just to touch base with folks we have in the call, and we don't have everyone here, about priorities for the next release. I think we all agree that a robust build, install capability is at the top of the list. Is there another way to characterize that? I think it has to do with what end-to-end tests we're able to run. And can we be a little bit more specific in identifying where we hope to be by the end of October? Or not?
End of October?
Well, so nominally end of October is 3 months, and we're giving ourselves a month to harden and do release candidates, which is sort of where we were with the previous release.
I think we should. So there's the stable build process that we want to have, and the set of tests that we can run. So these are largely being built out right now. A part of the automated test, the automated nightly test, which is building a pod every night, and we'll continue completing it as more and more things get automated. For example, right now, I mean, we can go up to the point of essentially booting a compute node and verifying that it's been provisioned correctly, but we don't have, say, the fabric automated part in yet. So I can't do an end-to-end ping across the fabric because it doesn't come up in an automated fashion just yet. But once we have that, that'll come in.
And then wouldn't running Cord tester tests against the automated build also be part of that process?
Yes, absolutely. But the Cord tester also relies on the fact that other parts have come up, that we'll do manually. So all these things will get rolled in, but all in good time. I don't wanna rush it just because we want to put up tests,
So that's great. I wanted to try to get a sense.
Larry,
I wanted to try to get a sense of what the.
Is that a good definition of?
Yeah, it is. We have an end-to-end auto build with Cord tester. Yeah, that's able to run nightly. That would be sufficiently.
Larry,
so I separate out, and maybe
Larry, you're cutting out.
So are you. Let me try again.
Ali, can you hear Larry?
So I can hear Larry in and out.
And I hear you guys.
I figured that was only me.
All right. So yes, that is a reasonable target. I include, or I have as a separate item, but I believe there's overlap, that we have full OAM capability, which includes a combination of all northbound interfaces having been plumbed through, but I believe that is part of auto configuration as well. And, well, that's the main thing.
Well, I thought one of the other main things was to get M-Cord and E-Cord onto the same platform.
I was going to come to that one next.
Yes.
So if we're okay on these first two, or 1.5, depending on how you want to slice it, on the issue of M-Cord and E-Cord, I am growing increasingly worried that we're not going to have them at a state we want.
So I would argue that E-Cord we're relatively close. At least from the last time I spoke to E-Cord, it seemed that we were relatively close. But M-Cord to me seems like it's harder to put my finger on it and understand what's really going on and how they've built up everything and how many of the hacks or the shortcuts that have been taken are because they're dealing with closed proprietary VNFs that they cannot that have a previous history. So I don't know.
Yeah,
it's harder.
My plan of action was that so see, E-Cord people are E-Cord is relatively easy based on what they have done so far. Now, what they have done so far is not very production quality, or not quality. I'm sorry. Some of the things that they're doing to do E-lines, those things I think are better done in hardware. So I want to get that going, and we are making some progress on that front. So E-Cord will come along. M-Cord, my next goal was to start working with Ping to truly understand where they are, and like Ali suggested, to try and see, are they getting past the hacks? So
what I would suggest before we dedicate engineering time from the core team, I would really encourage them to build out the pod with our own build out the platform the way we tell them to build out the platform.
But the Ping is still is doing that, right? So the point is, unless we have someone from the core team working with them, we're never going to know exactly what they're doing or what the status is. So
I understand. I understand.
I didn't set E-Cord in motion.
I understand. Just
I wanted to now work with M-Cord.
Yeah. I understand.
So can I?
Hear me out though.
My opinion is that while we all see the possibility with E-Cord, it's still very much at risk, and it will only be with resources from the core team that we're going to get E-Cord across the line, even though we think we understand how to do that.
No, but hold on. So the point is get them to build out the pod with our own, get them to build out the platform, get them to try to integrate their VNFs onto the platform, coming to us with specific questions along the way, right? Okay, because if they're trying to build something on the hidden roadblock, that's what we need to know. We need to know how this is, why they're hitting a roadblock, and whether it's an architecture problem in E or M with it's a problem with the platform. But we can only do that step by step at every roadblock we hit. We can't just, I mean, if Saurabh, you want to go ahead, I think you'll find that a lot of your time will be wasted there. I think it's let them build it out first. Come to us with specific problems along the way.
Yeah, but we said this a month ago, and has anything happened?
Well, I mean, I can't arm twist them into building things out and coming to us with problems, right? This is the problem. This is what I said last time, is if you want M-Cord and E-Cord to integrate, then they're going to have to focus one release on integration and not on adding new features. So I mean, you can't have it both ways.
And that is
you just can't.
That is the fundamental problem. I've had a number of conversations with the eCord team, and when push came to shove on what needed to be done, they basically said we are spending most of our time on packet optical and not eCord. That's not going to get eCord into the next release.
No.
Well, I think that's true.
So it's a question of priorities.
Yeah.
IACA.
Well, I think this. I wanted to bring the issue to the forefront because I think we have different opinions on what. There's a very high risk that we're not going to get eCord and mCord. I think we have to admit that. I would really like to get the other stuff done and not put that at risk as well, trying to bring eCord and mCord along. That may have to be what we do in the next release. But I think generally, Ali is right that we have to let the eCord and mCord teams help them understand that it needs to be a priority and be responsive, but not. We can't do it for them. We just don't have the resources.
Well, we also don't have the domain knowledge, to be fair. When we did this for our Cord, it was easier because we built our Cord, right? We did our Cord, so it was easier to correct our Cord and put it back onto the platform. But for eCord and mCord, it's a little harder, right? We don't have the domain knowledge. We don't have the understanding of why certain decisions were taken one way or the other.
Right.
So it makes. I think if I were to spend time with mCord, for me that would be a lot of time wasted.
So I do have one very narrow, specific thing I believe we're going to need to do for eCord, and I think pseudo-wire might be the answer, but we are going to need a way of, and maybe it's an extension to VTN. I'm not sure, but we're going to need the plumbing that gets us from the container as a first step out to the external backbone switch. And I believe, I know, Saurabh, maybe you've started talking to folks about that, but that is tied in with a whole lot of other stuff that we need to get coordinated. So I think there's some parallel conversations going on that probably need to be coordinated a little bit.
Yes, I mean, as far as these conversations happening, I mean, we just need to make sure that we're not duplicating work. So
yeah.
Good that these conversations are happening. It's good that in eCode we've identified two, 3 points which needed improvement in the platform. That's good. Let's go with that. But they definitely need to be advertised in Jira and scoped out properly.
Yep, I agree. All right, so with that raising of awareness, keeping our eye on the ball on what we can control. Is there anything else to discuss?
I think Bill wanted to say something.
Yeah, I don't know. Maybe I still feel like sometimes this is upside down, right? I really think mCord is responsible for defining their priorities, and if their priority is to get onto this release that's coming up, then they have to own that and drive it, right? Why are you feeling like you have to drive it, Larry?
I agree. That's precisely what I'm saying. Is put them in the seat where they have to integrate integrate with the platform, and when they have issues, come to us. That's what we're here for. That's how we can help them. But us going around and trying to herd the cattle into order is not gonna. It's just not gonna. I mean, it may work. It's just that it's
right. Just to answer Bill's question, we're the Cord Tst. We think that the right thing to do would be to bring everybody under the umbrella onto the same platform earlier rather than later, right? Now, if you go and ask the mCord team what is their priority, they'll say demos, new features, attracting as many people as possible. This is not their priority, right? So that's why there is
Right. So then we need to fix that priority problem, right? You know, with the discussion.
I mean,
Yeah,
also the eCord and mCord leaders are on this TST. They're members. They're part of this TST, right? So if
But
they
never
wanted,
come, right? So what's the point?
well, I mean, they have to come, right? I don't understand why they don't come. Like, I mean, like, it's not up to me to go, like, you know, whip them into submission. If they don't come, they don't come. But the point is, like, if the TST votes that the priorities for E and M Cord are integration, right, and these people are part of the TST and they vote for or against, then that's fine, right? Then we have a decision. But I think everyone agrees that that's what they need to do. They are also put under pressure about adding these new features and moving forward, which
I
these
think
two
there's a
things.
little bit more. I completely agree with everything that's been said. I think there's a little tiny bit more to it, which is, and I see it on both sides. Recently, I've been focused on the eCord side a little bit more personally, and I think they're looking for some direction. There's a little bit of just not quite knowing what to do next, and
Okay,
I'm
well
trying
then,
to offer. I'm working with that team to try to nail down an incremental set of tasks, milestones that we can shoot for. And in the process of doing that, we are exposing some holes. That's great. That's what we need to be doing. But the point is, I don't think it's necessarily going to happen without a little help from the TST broadly.
okay.
I think in the MCOR case, and the same thing for Jolt not being on here, is this needs to be addressed. Either they're here or they're not on the TST, right? And this is bullshit to not have them here when decisions need to be made, right? Just waste everyone's time. So let's make that clear.
Okay. I gotta run. I have to go
Yeah.
right now.
Thanks, everybody.
Thanks, guys.
Thank you.
Bye.